Okay, now we're going to look at similar figures. Similar figures have identical shape, but not size. The corresponding angles in similar figures are equal in size, but the corresponding sides are in the same ratio given by the scale factor. The scale factor is listed down here. If a scale factor works out to be greater than 1, then the second figure has been enlarged from the original figure. If the scale factor is between 0 and 1, so it's positive but less than 1, a reduction has occurred. Like congruent figures, we have some tests for triangles. Triangles can be checked using one of the tests described below. If all corresponding angles are equal in size, is the first test, AAA. If all corresponding sides are in the same ratio, SSS. If two pairs of corresponding sides are in the same ratio and the included angle is equal in side, that's our SAS test. And the final test, the RHS test, in any right triangle, the hypotenuse and one other pair of sides are in the same ratio. So if we look at worked example 11 from our textbook, it says find a pair of similar triangles from those shown below. So which of those triangles are similar? Let's go back to look at our tests. AAA means all corresponding angles are equal in size. We only know one angle, so it's not the AAA test. SSS, all corresponding sides are in the same ratio. We only know two sides. It's not going to be the fourth one, RHS, because it's not a right angle triangle. So is it SAS? Two pairs of corresponding sides are in the same ratio and the included angle is equal in size. So let's have a look at that one. So the first thing I'm going to do is compare triangle A and B. The included angle in both of those is 30 degrees. Now let's look at the scale factor from the sides. So if I look at these sides here, image length is 15, the original length of that side was 10. So that is a scale factor of 1.5. How did I get that? 5 goes into that twice, 5 goes into that 3 times. 3 over 2 is 1.5. Let's look at this side, 9 to 6. So it is 9 now, it was 6. 3 goes into that twice, 3 goes into that 3 times, which is 3 over 2, which is 1.5. So let's look at our rule. Two pairs of corresponding sides are in the same ratio. They certainly are. The scale factor is the same. And that included angle is the same. So we can say that A is similar, and that's what we use for similar. A is similar triangle to B, and how do we know? We know the SAS rule. We just better check the other triangles here, so let's check maybe A and C. So A and C. So if we're checking A and C, 15 started off as 6 and 20 started off as 10. So 15 over 6 and 20 over 10. So that's a scale factor of 2. That's 3 goes into that twice. 3 goes into 5. That's a scale factor of 2.5. So the sides of A and C have not they're not in the same ratio. So now let's also check B and C. So with B and C, 15 started as 9, 20 started as 15. So it was 15, it is 15 now, it was 9, it is 20 now, it was 15. 3 goes into that 3, 3 goes into that 5, 5 goes into that 3 times 5 goes into that 4 times. So 4 over 3 and 5 over 3 are not in the same ratio. So what I've shown there, that A and C are not similar and B and C are not similar. But A and B, they are. The rule is the SAS rule. And let's go back and read that again. 2 pairs of corresponding sides are in the same ratio. In other words, they have the same scale factor, and the included angle is equal.